All right, team. So, if you guys remember back at the beginning of the year, we did some learning for our external. The reason why we did some of that learning was to help give you guys a basic understanding of atomic structure and also to help prepare you guys for the ion identification. So, if you guys remember, we did some introduction stuff. We then did metallic solids because that one, in my opinion, is probably the easiest one to understand. And then we did ionic solids. And then from there, we stopped because you see there's a big break here from this one to this one because we then went on to the ion identification internal. The reason why I wanted to do that is one, I needed to make sure you understood some basic properties of chemistry, but two, there was no point in me teaching to you guys this at the beginning of the year when the exam's at the end of the year and you're going to forget everything. So that was the thought process. So just trying to refresh your memory. When we talked about types of solids, if you guys remember, there were 4 different types of solids, and the first key for this question is being able to classify it correctly. If you misclassify, it's going to have a horrible snowball, and whatever you write up as your justification is going to be marked as incorrect because everything you're saying is now not right for that type of solid. So if you guys remember, we had this little summary table to help us remember what was what. And we also had lots of Cahoots and things like that. Not Cahoots, Cahoots, and I think a GIM kit. So metals, the way we have to find it is on the periodic table. You're looking for any metal elements, and it's going to be in the pure substance. They don't usually do alloys or anything like that. So that's how you find that guy. The other thing, sorry, just going to go through that first. Ionic solids, that's one you guys also covered as well. That's going to be a metal and a non-metal together. So you're looking at 2 opposite sides of the periodic table. If you have those 2 opposite sides, then that is your ionic substance. Covalent molecular and covalent network. Both of them are going to have non-metals and non-metals only. So that's going to be on that right side of the periodic table, just a very small section of atoms that could be that. In order to distinguish these two, the trick I gave you was the covalent molecular is going to have low melting or boiling points. They will be gas at room temperature. So if you're not sure which one of the 2 you have, read the rest of the questions, see what hints they provide you, and if they mention anything about melting or boiling points, then you know it must be that guy. Covalent networks have the highest melting or boiling point. So that is in the opposite direction. Again, it often helps to read the whole question to see if there's a hint like that. Covalent networks are usually limited to graphite or diamond or silicon dioxide. So they usually only ask those guys for the covalent networks. So again, you can use process of elimination to figure out, do you have covalent molecular or covalent network? Are we okay with that so far? All right. If you guys want practice reviewing that, you can go back to the previous lessons. I did put onto this lesson. Let me just go back to number. See, everything's there. Oh, I forgot to do that. Got a link on my websites. All right. For lesson number 4, I have linked in that GIM kit that we played previously. It's a good way just to make sure you know how to classify it because it's just going to have like 50 questions asking you to classify the various things. Classification, like I said, is the key. If you get that wrong, it's going to snowball very badly. So you see, there's all this stuff here. The other thing that I put on to kind of remember is the types of particles and the forces between the particles. There's going to be lots of potential properties that they will ask you about, like electrical conductivity, malleability. So can you smush it and will it change shape or will it break apart because it's brittle? Is it soluble in water? That sort of thing. So remember, whenever you're explaining those questions, you're tying it back to the particles that are there and also the bonds that hold together. Those are the 2 main factors. So you fill in that table first, you answer the written questions, you refer back to that written table so that way you know how to say, oh yeah, atoms are doing this is doing that, etc., etc. So that was kind of a crash course summary of what we've done. What we're looking at today then is our covalent networks. We'll skip the pre-learning because like I said, we're doing a little crash course in this. And then, like I said, you guys can have the rest of the time to move on to your journals. Almost grab your pencil case. Line. Here it is. All right. So when we are talking about covalent network, we're talking about things with big structures. There are 3 different types of covalent networks that we need to be mindful of. The first one is a 1D covalent network. So whenever we say network, we're talking about big structures that are quite complex. The first one is a 1D one. You will probably not get a question on this. 1D covalent networks, the example that I have for you guys is plastics. So what we have is a single monomer chain, like that. and then they are attracted to another chain of things as well. Like that. So what you'll have is between our atoms, we'll have covalent bonds. That's why we call them covalent networks. And then between these little layers of chains, you will have the weak intermolecular forces that hold together. All right. Plastics obviously have a huge range of possibilities. They can have really low melting points and boiling, or sorry, not boiling points, really low melting points. They can also have really high ones because you can put some of them in the oven. They don't often ask about the 1D networks, but I do need to teach it just as background information. So this is unlikely to get asked in the exam. The other two are much more likely because they have unique properties. The other issue with 1D 1D covalent networks and the plastics is that they have a lot of overlapping properties as the moleculars, and so that's why they kind of don't use that question. The next one we have is the 2D networks. What am I doing? 2D networks. The main one they're going to ask you about for this one is graphite, which is exactly the same thing you guys find in your pencils. That is just carbon. So they often note this as carbon solid. Now, the thing that's special about this guy here is that you have these, what's the best way to describe it? You have these sheets of hexagons that make up a graphite, like that. Pretty, aren't they? So you have these sheets of graphite. Each one of these is a carbon atom, and each one of those carbon atoms are bonded to 3 other carbons. So that guy, 1, 2, 3. You then have another sheet of that. So many hexagons. Hate drawing hexagons. Ah, there we go, hexagon. So this is representative of the carbon sheets. These again have covalent bonds. But because it's a sheet instead of a string, you have lots of intermolecular forces. So you have that. There's lots of layers of intermolecular forces going on. I spell today. Sorry, guys. Trying to be quick. So these guys will have a high melting and boiling point. Again, that's how you're going to find them. The other thing that's unique about graphite compared to other things is that because the carbon only has 3 bonds instead of 4. So carbon usually can have 4 bonds. In this case, it only has 3. And because it only has 3, you then have a free valence electron that can be mobile and can conduct electricity. So if you guys remember when we did this in the ion identification, in ions and in metallics, one of the key factors for conductivity as a property is you need to have a mobile charged particle. The mobile charged particle could be an electron or an ion. In this case, it's an electron. So when I'm talking about graphite, because it only has those 3 bonds, I then have a free electron to move around to conduct my electricity. You good? All right, last thing that they can ask you is about the 3D covalent networks. So that one is going to be diamond. It also often is silicon dioxide. So again, diamond would be shown as carbon solid. So both of these are carbons. They're different allotopes of each other because they're just different structure and bonding patterns. So for example, if I was dealing with diamond and I had all my carbons, it's going to be in this 3-dimensional shape where you have every carbon is bonded to another carbon like that. So it's in that 3-dimensional shape and it has 4 bonds. So again, this is only have covalent bonds. So both of these will have high melting and boiling points. That's the distinguishing factor. This one, however, because we now have 4 bonds to that carbon, it has lost its electrical conductivity. So this one's not conductive. But it does have a high boiling point and melting point. And same thing with our graphite. Okie dokie. That's all I want to tell you guys about that. And then I'll show you guys an exam question, and then that's us. Yeah, that's my shorthand. Don't do it on the exam. You can do it on the mock exam because I know what you're saying, but don't do that for the end of your exam because they may not know that's what you're referring to. No, this just means carbon because these are both carbon. These are both made up of carbon. So both of these are carbon solids. They're just different allotopes of each other. So the only thing that's different between these two is how the carbon's bonded. In this case, this carbon is only bonded to 3 other carbons, and it's acting like a sheet, and it's sheet on top of sheet. Whereas this one, the carbon has 4 bonds. So since this one has the 3 bonds, you then have a free valence electron to move around to conduct electricity. The moment I put that carbon into another bond and I make diamond, then I'm going to lose that conductivity because it now doesn't have the free valence electrons. And the other important thing to, like I said, to remember is that when we are talking about the 2D covalent, we're talking about sheet. So a sheet and a sheet having lots of intermolecular bonds. Whereas when we're talking about 1D plastics, we're just talking about lines. And they will have, obviously, attractions to each other, but they're not actually connected together. They should not ask you a question on 1D covalent networks, though. Because 1D covalent networks are very different from 2 and 3D. They keep to the 2 and 3D. Are we good? All right, let me show you the exam question, just so you guys know where this is all going, and also talk about kind of things that you're going to do. So the 2022 question B, sorry, 3. Find it. Come on, internet, you can do it. Just want to show you guys where you're working towards. All right, so here's question 3. You can see again, they are asking you to classify the type of solid, classify the particle that it's made up of, classify the forces involved in there. Looking at the marking schedule, I think that's probably only an achieved point. Sometimes it can be a merit, but usually it isn't. Oh, no, maybe I'm wrong. Usually it is a merit. So you see this one, 2 columns or 2 rows correct, table correct fully is a merit point, which I think is a pretty easy merit point. Then some things you got to be mindful of classifying. So you see here lithium bromide, metal and non-metal, that's my ionic. Diamond, we just talked about, that's a covalent network. And then we see here we have a mixture of non-metals. So that must be another covalent. This is going to be the covalent molecular. They often won't, I've never ever seen them to give 2 of the same. So you're gonna, if you've already labeled something as covalent network, then this one's covalent molecular by default. And if you go read further on, it should say something that kind of gives you a hint that it is somewhere along the lines. Anyway, this one here is talking about diamond. Both naturally as graphite and diamond are found. Graphite conducts electricity, while diamond is an electrical insulator. Use your knowledge to explain this. So that was exactly what I was just talking about. And again, that one goes up. So achieved is just stating things. Merit is linking them together. Excellence is actually full comprehension. Make sure you're talking about the substance that they've actually provided you. And that's all that question's looking like. So, just so you guys are aware, there are the SciPad pages I recommend you guys do. Remember, do as much or as little as you guys need to do. Also, feel free to jump around. So if you feel like I actually understand this, you can skip the SciPad and go directly to No Brain Too Small and do those collated questions. It's not a tick boxing exercise. I'm also happy if you just want to read the theory that's on those SciPad pages and just skip the questions. It's just whatever you need to do that's best for your learning. There are some extension SciPad pages that I've also provided as well. They are stuff that is useful to know, but I haven't seen actually come up on an exam. Then there's some summary pages as well. The summary pages are quite good because they do have a covalent network exam question and they tell you how to structure it. Oh, that didn't link. I need to put that together. And then I've also put a CPR quiz down there as well so you guys can practice the write-up. The CPR quiz is a little bit harder. I did take it from a mock exam, which makes it a little bit more challenging. This one they haven't told you what you have, but they've classified it for you. So it's more or less the same thing. All right. Cool. That is us. Let us move on to anyone that needs to make up some internals. And if you don't need to make up an internal, you can work on those external.